Hello and welcome to the ninth video in lesson 1. Here we will talk about the total energy analysis method for demand analysis. In this video we're going to talk about the basics of the total energy method, and we will talk about when to use it, and we will showcase also how to actually input that in a very simple manner. So the total energy method, which is one of the 4 demand methods, analysis method in LEAP, is showcased by this little red gear in front of the technology, for that matter, and that's how you recognize it inside the LEAP structure. So what is the technology with total energy? Well, it is the simplest method to project energy consumption in any given sector. It's very explicit. You just project the energy demand from your given sector or subsector, literally. So it only projects the energy use. There are no other parameters. There are no causes. There are no side calculations needed to do this. So, and the unit will always be expressed, the input unit will always be expressed as in a energy form, for instance, gigajoule or terawatt hours, megawatt hours, etc. The problem, which is a big one for total energy, is that it doesn't show explicit causal relationships. So why does the construction sector increase by this much over the lifetime or on our predictions? Well, it doesn't tell you. If you have differences between scenarios, why that difference is happening, you will not tell anybody in this with this method in the model. So it should only really be used when you know very, very little about the sector. In LEAP, when you put it in as a technology, as I did here and under the name quote-unquote test, you can see I just specified a 2010 value. That's in this case my base year, and then from then on I just directly projected the number of gigajoule forward with an interpolation function. Of course, other functions can be used as well, which we will delve into. When do you use total energy? Well, again, you only have very, very simple statistics to work from. You may have a general idea of where the sector is going. However, if it is an important sector, like industrial sectors, transport, that does show quite a lot of development, I would not use this method. You can also use it really well if your projection is generally based on, for instance, GDP or another sector, and you have an elasticity with that. So you could, if you have a not so important sector, you can just have it for GDP and elasticity, which you can do quite easily with a growth as function. Otherwise, you could, for instance, have some kind of measure in your system that shows how much your housing is, urban housing is developing in your area, and have a more complex way of analyzing that, and then using that as a method with total energy to project your construction energy consumption, for instance. But again, only if you have very simple sectors and you don't know very much. Otherwise, it's not recommended to use.
Here we have the screen capture of LEAP. This is the standard Fredonia model, as you can see, and I quite frankly think it needs a demand for the agricultural sector. Now, in this case, in my statistics, I don't know a lot about my agricultural sector. It is projected to grow with 1% per year, and also I can tell now it is the energy consumption in the sector is around 500 gigajoules. So let's try to express that in Leap, and then figure out. So the first thing I do is go into the current accounts because I want to put my statistics, and then in this case I want to add a new category. So this will be my agriculture sector. So this just functions like a folder in Windows or something similar. So now I have agriculture. In my agriculture, I can now add my technology with total energy, and I'll just call this, in this case, agriculture, because as said, I don't know much. It is known, however, that it runs mostly on diesel, or it runs on diesel in this case. Again, I'm trying to express something very simple. You could have multiple technologies under agriculture that you then could use. So, we put this in, good. Now, in terms of total energy, I think I said it was gigajoule, so there you have the unit over here on the right. That is already gigajoule, so that's good. So we'll input that to be 300. Good. Now we have a starting command. Now I will change my scenario to be the baseline scenario, and I will change this to be growth 1% per year. Oops. It's helping me too much. Not good. And apply that, and now we know that it grows. So let's see if this runs. So I'll go over into the left, click on results, and now it's going to go through quite a lot of the model. And most of this right now I'm not interested in. What I want is I want to see the final energy demand, and I want to see it only for agriculture. You can see I start at 300 gigajoule, and in 2010, where my statistics was for this model, and by 2040 it's more than 400 gigajoules. Specifically, we can see this in the table that we are at 404 gigajoule in 2040 in this scenario. And we just look at baseline because we have not input anything else.